ladies? All right. Morning. All right, inverse functions. So inverses, tell me what you think when you hear the word inverse. Opposite, maybe backwards kind of thing. So that's really inverse functions. If I gave you, let's see, 2, 3, 4, let's say this was 4, 6, 8. If I told you that this was a relationship, and it is a function, and why is it a function? If I just look at that relationship.
Because they have, like, you multiply by 2.
But what makes it a function? What's the definition of a function? Okay, it does have to do with input output. Every input has one and only one output. Okay, so you can't repeat, you can't have y'all heard of the vertical line test when you graph? Oh, no. If you have something like, let's do like a cubic graph that we've been doing, okay? If you take a vertical line and you run it along this graph, there is never any place where the vertical line will intersect the graph twice. But if I looked at something like a parabola on its side, and we'll talk about that. If I ran a vertical line along this, it would intersect twice, right? That means that this x value, let's say this was 2, 5, and maybe this is 2, -5. This x value, it's got 2 outputs for that one input, okay? So that's how I know if it is a function or not, okay? Every input has one and only one output. So this is a function. Now when I talk about the inverse of this function, the inverse of this function is, and tell me what I did when you see it. This is easy. I flipped around the input and output, okay? That is what inverse means. It's switching the x and the y. That is essentially what it is, okay? Graphically, if I look, I'll give you all a second to copy that. Then I'll.
So the right inverse function will be the 2.
Yes. No, wait, what? Don't look at these for inverse just yet. You told me that inverse was opposite. We use the term inverse a lot when we're solving equations to cancel out certain operations, right? Mm-hmm. The inverse operation of multiplication is division and so on. So I want you to think about something with me for just a minute. Let's look at a quadratic because we're good with quadratics, right? Let's just take y equals x squared, which has the points 1, 1, -1, 1, and 0, 0. If I found the inverse of this function, I simply would switch the x and the y's, okay? So 0, 0 is still 0, 0. 1, 1 is still 1, 1, but -1, 1, 1, -1. It just, every x and y value switches. So that's what inverses look like on a graph. It's basically just flip. You could literally lift up, if you could switch the x and the y axis and move them around, same thing. Think about that parabola and just twist it around so that the x becomes the y and the y becomes the x. Okay? That's what inverse means. Now, suddenly what we had was a function, and now the inverse is not. Do you see why it's not? Yes, Miss McKee. If I drop the vertical line, it crosses twice. So it's no longer a function. Okay? All right. But what we're going to do, that's just kind of a broad introduction, and we'll use a lot of this for the next lesson. The green line is just showing that if you dropped a vertical line, you could find a place where it intersects twice, which means it's not a function anymore.
So down function.
The pink one is, and the whatever that color is not. Yeah. Yeah. Beige. Palmer's favorite color. Beige. Isn't that what you said yesterday? Oh my goodness. Okay. Let's talk algebraically because that's really where we're going to focus today. Let's say I have the equation f of x equals 3x minus 5. And I want to find the inverse. Again, what do inverses do? Switch what? The x and the y, right? But I don't see a y.
F of x equals 1.
Good job. F of x and y are synonymous. So if I switch x and y, okay,
X equals 3y minus 5.
but I want an equation of the inverse.
Oh.
Okay.
To find inverse, told me we switch x and y. I can't deal with this heat in here. Switch, are you? I'm going to crack this door up a little bit, y'all, because I'm about to die.
Go ahead.
All right, we switch x and y, and now what you got to do is you got to solve it back for y. You got to get it back in the form it was originally in. That's all you have to do. So we're back to our sad map stuff, right? Why are we what? We're not switching it back. We literally move their places, and now we're going to solve it for y. Because we want the equation of the inverse. So in other words, if you think about that graph, that parabola, if we wanted the equation of the beige one that was like this, that would give me, switching x and y and solving gives me that next equation.
What's the point of doing that if y was already
Y was already like this before I switched x and y. But now that I've switched x and y, whenever I solve...
The original equation is not the inverse.
Correct.
You have to solve it.
Correct. Go ahead.
What are we... What is the goal on this one?
The goal on this one is to find an equation for the inverse. So given an equation, what's the equation of its inverse? And so the equation of its inverse would be x plus 5 over 3. Not yet, no. So if you were to graph, however, because I think everybody's confused about what it is we're actually doing. Okay, so if I were to graph this, of course I go down to -5. 1, 2, 3, 4, 5, and then I go up 1, 2, 3, and over 1. So that's the first line, right? If I graph this, the y-intercept is 5 over 3, which is almost 2. And then the slope is 1/3, so I'd go up 1 and over 1, 2, 3. Those two lines are inverses of each other. The x and the y coordinates have been switched. Okay? So you're essentially finding the equation of the inverse. So y equals 3x minus 5 and x plus 5 over 3 are inverses of each other. Just flipped it around. Let's do one more.
I feel like you don't even have to, you can just look at that.
Exactly. You just feel like you just changed the sign.
This was an easy one.
Just change the sign.
Yeah.
For x equals 3y minus 5, you have to add 5
Go,
in order
Corbin.
to get x. Or,
In order to get y by itself. So you added 5 and then divided by 3. Find the equation of the inverse. Let's say f of x equals -7x to the 5th plus 7. Try it on your own, then let's do it together. Y equals -7x to the 5th plus 7. Switching x and y, this equation becomes x equals -7y to the 5th plus 7. So the first thing I'm going to do is move the 7 because I'm sad mapping here. And then I am going to divide by this -7. You have to divide everything over here. I think that's where some of you are getting confused because you're just you can't just cross it out right there. Because you have to divide that whole side by -7.
You can cancel those.
You could, but you would have to split it up like we talked about, splitting up the fraction. But what I would do is I would go ahead and do this. And I would find that the inverse, and by the way, let me show you a new notation. Just if you see it, you don't have to use it. This means inverse f of x.
Nope,
Oh,
not
okay, no, okay, don't do it. Take it off, erase. I'll take it.
Oh, no.
Just know that should you see that, if it comes up,
Is that a negative one?
that means inverse. It's a negative 1 exponent. On the f, not on the outside.
Inverse cosine.
Yeah, exactly. It's exactly like that.
remember what cosine is.
All right, so the inverse of f is the 5th root of x minus 7 over negative 7. I will tell you this.
You can't.
Do not.
Simplify that.
You could if you wanted to break them up. I don't want to.
Well, I mean, just like, can't we just make it x plus
Yo,
one?
what the ages?
If you split this up, it would be x over negative 7 plus 1. And everything's still got a 5th root over it. I would just assume leave it like it is.
Do we have to graph on the homework or are we just?
This is half of it though, y'all. I gotta get through the other.
It's not a way.
All right, let me show you the hard part of the lesson.
That wasn't it?
I love watching Miss McGee's YouTube videos.
Thank you, Palmer.
I do shouldn't watch that.
All right, verify inverses. Sometimes you are given two functions. Let's say, in fact, let's use the two that we just did. If f of x is, no, I forgot what we just did. Give me the equation. Thank you. When we found the inverse, what did we find the inverse being? The 5th root of x minus 7 over negative 7.
Why didn't you sit in
Because this is when you verify, you have to verify before you can. This is kind of like when you prove things in geometry. Okay? You know what it's going to end up being. The work is in the middle part. Okay? That's going to be the same thing here. I'm going to give you two functions and I'm going to say, hey, these are inverses of each other. Now prove it. So to prove it or verify it, you have to do two things. Okay? You have to compose them. You have to find f of g of x, and you have to show one step at a time that it simplifies to x. And then you have to find g of f of x and show one step at a time that that also simplifies to x. And by doing this, then, Kirkland, we could rename them f of x and inverse f of x. But until we've proven it,
But of course they're equal one another because they're.
not equal one another, but
When you
equal
plug them
x, when you plug one into the other. So let's work through it. You're not, this is not multiplication, this is composition.
Yeah, it's complicated. Remember when we plug things in the last chapter?
All right, this gets sticky, so stay with me.
Before we start this.
Alright, so are we basically just like doing the composition and then after we get done, we're plugging in y, correct?
You don't have to do any of, if it says find the inverse, that's when you switch and solve. If it says verify, that's when you compose and simplify. Yeah.
Wait, so it's not even an inverse?
Making a cold brew.
I'm telling you, I'm think that they are inverses. I need you to show me, prove to me that they are inverses.
It's probably.
I have a question.
Okay, go.
Okay, so, do you remember what you said, like, as you were writing the g of x? Because I need you to start there. What?
Okay, so I'll give, okay, I'll start by giving you two functions, and I'll say these two functions are inverses of each other. F and g are inverses of each other, okay? I'm now asking you to find the inverse. I've already found the inverse. Now what I want you to do is verify or prove to me that they are inverses, and the way we do that is by showing these two things.
Oh, so they should come out to be like.
They should come out to be x. When you do f of g of x, it should come out to be x. In fact, it will come out to be x. The work comes in you showing me how it comes out to be x.
So you just do those two?
Yes.
I'm gonna do the best. I learned to do like fractions. And
Yes.
I don't even know how to do that.
Watch. All right, let's do f of g of x together first.
-7 and then.
So f of the fifth root of x minus 7 over negative 7. So everywhere there's an x in f, I'm replacing it with the fifth root of x minus 7 over negative 7.
Wow.
Now,
You.
all right, watch what happens. Negative 7, it's not x anymore, it's fifth root of x minus 7 over negative 7. Now look, you already know every single stinking thing in this equation is going to cancel out except the x. Thank you. Okay? But if you get on your test and you do this and then you go,
What?
I am not going to give you credit for that. Yes, that is true.
You got the answer.
I'm giving you the answer, though. I'm giving you,
Technically is what you're doing.
I'm going to tell you, verify the following are inverses by showing that f of g of x equals x and g of f of x equals x. I'm telling you what it's going to come back to. Show me why. Why does it come back to that? So order of operations, what cancels out first here? Exponents. This is gone now, right? So now I have negative 7 times x minus 7 over negative 7 plus 7. Okay? What can I do now? That's right. They do cancel out. Now, if you didn't recognize that or realize that, you could distribute that negative 7 up top. But because I know, because I'm a good Algebra 2 student, that if I'm multiplying in the top and it's going to everything, and this is the only thing in the bottom, and they are the same, I can cancel them out just like that.
Really?
Huh?
Now we're just level.
Can we not take that shortcut and just,
No.
X plus 7. They cancel.
Negative 7 and positive 7 leave you with x, and so it verifies one way. I have to also verify the other way. Some things will compose to x forwards, but not to x backwards, so they will not be inverses of each other. In order to verify inverses, they must compose both ways. Let's do the backwards way of it.
You know, I've always felt this.
I don't feel good.
G of negative 7x to the fifth plus 7. Okay? So, the fifth root of negative 7x to the fifth. This way's easier, I think, in this problem, over negative 7.
Well, the plus 7 minus 7.
That's what we cancel out already.
it's
Right side each other.
Because, and here's where you might start getting confused with order of operations. Fractions group things together. I could essentially put a parenthesis here, right? Parenthesis on the denominator. So they're grouping. When you say parentheses with order of operations, you're talking about any type of grouping. Okay, so that has to come first. So up top, yes, you're right, Kiana, the 7s are going to cancel out. Don't do this to me today, computer. And so it leaves me with the fifth root of negative 7x to the fifth over negative 7. Hey, can I cancel the 5s out now? No. Why? The 7s, because they're grouped together under that radical. So I have to do any type of simplification under that radical first. So the 7s cancel. Now I have the fifth root of x to the fifth, and yay! It's gone now.
I'm having a mental breakdown.
I guess it's okay.
Yeah, like.
My brain is